All right, let's try a couple more practice problems. All right, number 3. I want you to graph g of x equals 2 times 1/3 to the x plus 4 power. So go ahead and pause your video here and try the practice problem. All right, if you tried the practice problem, let's check it. Again, this is exponential. This time the base is 1/3, which is a hint that this is going to be an exponential decay function. So if you're checking your work, the original points on our parent function are -1, 3, 0, 1, and 1, 1/3. And our ending points, and our asymptote is y equals 0. Our transformed points would be -5, 6, -4, 2, and then -3. This would be 2/3 or 0.67, depending on if you used a decimal approximation. And then we would have still y equals 0 as our transformed function. And here's what the graph looks like. So our asymptote's at y equals 0. And then plotting these points. We have a point at -5, 6, -4, 2, and -3, 2/3, which is just a little bit above the axis. So that's going to be exponential decay like that. We knew it should be exponential decay since our base was a fraction between 0 and 1. Okay, if you didn't get that, if you didn't get those points, let's go over where those are all coming from. So on any exponential function, any function that we're graphing with transformations, we need to find the parent function. Our parent function in this case is f of x equals 1/3 to the x power. This 2 is not part of the base. The 1/3 is the part to the power, so that's the base there. So like always, we use -1, 0, and 1 as our x values. And to find our outputs on our parent function, we're plugging them into the parent function. So this one would be 1/3 to the -1 power. If you don't feel like doing that by hand, just do it on a calculator. Let me clear what's in there. So I would have in parentheses 1/3, so 1 divided by 3, to the -1 power gives me 3. Okay, the next one I'd have 1/3 to the 0 power. Anything to the 0 power is just 1. And then lastly, I'd have 1/3 to the 1 power, which is just 1/3. So that's where my points are coming from for my original. So now let's do our transformations. Also on our original, our asymptote is always y equals 0. This was our parent function. So the first operation we would do would be what's in the exponent. The +4 is with the x, so that's going to affect the x values. And remember, with the x, we do the opposite operation. So I would subtract 4 from the x values, subtract 4 from all the x values. I don't have to subtract 4 from the asymptote because that is y equals. All right, so my new x values would be -5, -4, and -3. And so far, my y values are just 3, 1, and 1/3. I haven't changed those yet. All right, now we got one more operation. This 2 is multiplied on the outside. It's not in the exponent. So it's not affecting the x, it's affecting the y. So when we have the x, or when we have something affecting the y, we just do the operation we see. So we're going to multiply the y values by 2. So my x values are -5, -4, -3. My new y values, this would be 6, this would be 2, and then 1/3 times 2 is 2/3. If you don't know what that is, you can also do it on a calculator. So 1 divided by 3 times 2 gives us about 0.67. Okay, now also let's talk about our asymptotes. So here, as I said, I didn't do anything to the asymptote because this first transformation affected the x values, but this one we're also multiplying the asymptote by 2 because it's affecting the y values, but 0 times 2 is still y equals 0. So these are the points and the asymptote we're using. Hey dude, you're okay. All right, so let's graph those. So y equals 0 is the horizontal asymptote. Notice I'm always drawing the asymptote in first. And make sure it's always horizontal. So here's our asymptote, and then let's plot our points. We've got -5, 6 means we go left 5 and up 6. -4, 2, and then -3, 2/3. 2/3 is between the 0 and the 1. So if I draw that in, it's going to look like this and get close to the asymptote there. So this one is exponential decay. All right, let's try one more problem. All right, number 4, we're going to graph f of x equals e to the x plus 2 power. Actually, let's make that a minus. Let's do x minus 2 plus 3. Okay, so go ahead and pause the video here and try this problem. All right, let's check. So this one is also exponential, but this time our base is e. And remember, e is a number that's approximately 2.72. So we could use decimal approximations if we need to. So the points on our parent function would be -1, 1 over e, 0, 1, and 1e. Now these are decimal. I could use decimal approximations as well. This, I believe, is about 0.37, and this is about 2.72. All right, so, and then our transformed points. The new x values are going to be 1, 2, and 3. And our new y values are going to be, I'm using decimal approximations, about 3.37, 4, and 5.72. Our asymptote is y equals 3. So if we graph that, those are very crooked. All right, our asymptote is at y equals 3. And then if we plot our points, this one is still exponential growth like that. All right, so there's what our graph looks like. Let's go ahead and go through this in case you didn't get this. If you did get that, then you can stop the video here. If you didn't get that, go ahead and watch as we go over this together. Okay, so this time it's still an exponential function because we have a base and a power. But this time our base is e. Remember we talked about e yesterday. E is a new number, approximately 2.72. So we can keep that in mind when we are finding our points. So our parent function here is f of x equals e to the x power. So like always, we have to find the points on the parent function. -1, 0, and 1 are the x values I'm using. So if I use this, I'd have e to the -1 power. That would be 1 over e if I write it as a fraction. But remember, we can use a decimal approximation. This calculator has an e button. Most scientific calculators should. If you don't have that, just use the approximation of 1 over 2.72. So if I do 1 divided by e, we get 0.37. So we can use that as our y value. All right, if we plug in e to the 0, anything to the 0 is 1. And if we plug in e to the 1, that's just e, which we said is about 2.72. All right, so those are our original points. Now let's do our transformations. Hey, buddy, you're okay. Almost done. Almost done. All right, we got two transformations. We've got this -2 with the x. Remember, with x, we do the opposite operation. So this one we're going to add 2 to the x values. Almost done. Oh my goodness, I have such a cranky baby. I think he's ready for a nap. All right, so this would give us our new x values of 1, 2, and 3. So far, my y values haven't changed. So 0.37, 1, and 2.72. Also, in our original, the asymptote is y equals 0. You're okay. I'm almost done. And since this one is not affecting, the first transformation is not affecting the x's, it's still going to be y equals 0. All right, the second operation is this +3. That's not with the x. So that's affecting the y. We're going to add 3 to the y values, including the asymptote, because that's a y equals. So now my points, my x values are still 1, 2, and 3. My new y values, this would be 3.37, 4, and 5.72. So remember, you can use decimal approximations. And then my asymptote is y equals 3. So that's where our coordinate points are coming from. So let's graph those. So I'm going to start with my asymptote first. Remember, that is a horizontal line. It's crossing the y-axis at 3. All right, and then let's plot our points. So 1, 3.37 is like right here. 2, 4. And then 5, 5.72. And then draw in our exponential growth function. You're okay, dude. So even though our base is e, which is an irrational number, it's just a number. So don't let it confuse you. It's not anything different. We're just using e, which there should be an e button on your calculator, or you can use 2.72. Okay, we're done for the day, and now I can put this baby down for a nap. Sorry about that, guys. He's a little cranky. Makes this a little hard to try to do this teaching from home. But I know we're all doing the best that we can.